Welcome back, everyone, to another Explainer. Today, we are unpacking a topic that literally surrounds almost everything we buy, the containers and packaging sector. But instead of looking at the cardboard or the plastic itself, we're investigating the massive, often completely unseen environmental footprint left behind long before these packages even reach our front doors.
Let's dive right in with a question. Think about the last cardboard box that landed on your porch, or maybe that aluminum can you just opened. What is the actual true cost of that packaging? We normally just think about the paper, the metal, or throwing it in the recycling bin. But, what about the massive resources required to physically conjure those finished products out of raw materials in the first place? Here is our roadmap for today. 1. The hidden packaging footprint. 2. Tracking heavy water use. 3. Danger in water-stressed regions. 4. Managing hazardous process waste. And finally, 5. Strategies for resource stewardship. Let's get right into it. Starting off with Section 1, the hidden packaging footprint, uncovering the stakes. Converting raw materials into the glass, plastic, metal, and paper we use every single day takes an absolutely staggering amount of resources. The sheer volume of water needed just for things like process cooling or steam generation is absolutely massive. It's a pretty intense industrial reality. Huge water inputs go in, and hazardous process waste often comes out. The operational and environmental stakes here are just incredibly high. So, how do we actually keep tabs on this? Well, this framework from the Sustainability Accounting Standards Board, or SASB, brilliantly lays out the exact metrics companies are required to report. It forces them to track hard data for water and waste management. It basically takes these vague environmental ideas and turns them into hard numbers that investors can actually use. Which brings us to Section 2, Tracking Heavy Water Use, the Measurement Lens. Let's see how this builds into the specific ways we actually measure this stuff. Okay, this is an absolutely crucial distinction: water withdrawn versus water consumed. Water withdrawn is exactly what it sounds like. It's any water pulled into the facility from a river, the ground, or a municipal pipe. But water consumed, that's a totally different beast. This is water that evaporates, gets physically embedded into the product itself, or is discharged into a completely different catchment area. Basically, it's water that never makes it back to its original source. And when this tracking fails, companies face formal government enforcement actions. These violations are meticulously categorized. You've got technology-based violations, which are things like failing to meet continuous daily or monthly discharge limits. And then you have quantity or quality-based violations. These are the big ones. Think illegal discharge of hazardous substances or pumping out more pollution than a local water body can legally handle. Moving right along to Section 3, Danger in Water-Stressed Regions, where scarcity meets operations. So, what happens when this heavy water demand collides with local water scarcity? Well, what exactly qualifies as water stress? Using the World Resources Institute's aqueduct tool, we actually get a very specific scientific threshold for these danger zones. A region is classified as having high baseline water stress if 40 to 80% of the available water is already being withdrawn. Anything over 80%, that's extremely high stress. Companies literally have to map all their facilities directly against this tool. Because it's not just about how much water a company uses globally, right? It's heavily about where they use it. Companies must report the exact percentage of their total water consumed in these highly stressed red zones. Drawing massive amounts of water in an area that's already struggling to supply its own local farmers or citizens, that is a glaring red flag for risk. Operating in these dry regions introduces severe constraints that can quite literally grind manufacturing to a halt. We're talking wild volatility in water procurement costs, direct competition with local municipal users, intense backlash from communities and NGOs, and the very real threat of regulators suddenly stepping in with strict restrictions on withdrawals. Section 4, Managing Hazardous Process Waste, the Toxic Byproducts. Remember, resource stewardship isn't just about what goes into the plant. It's about the dangerous materials that come out. The packaging sector generates some incredibly harsh byproducts. Depending on the process, facilities can pump out heavy metals, highly corrosive spent acids, spent catalysts, and dense wastewater treatment sludge. It's a stark reminder of why strict transportation and disposal regulations even exist. Mishandling this stuff leads to incredibly complex and expensive environmental liabilities. Now, when we look at tracking how much of this toxic waste is recycled, the standard makes a vital distinction. Burning it for energy recovery absolutely does not count as recycling. Real recycling means the materials are genuinely reused, reclaimed, or remanufactured. If a company just tosses combustible hazardous waste into an incinerator to generate heat, the standard explicitly bans them from calling that recycling. It stops them from artificially inflating their green metrics.
Which brings us to our final section, Section 5, Strategies for Resource Stewardship, Turning Risks into Efficiency. Okay, so we've mapped the problems and the measurements. Let's look at how forward-thinking companies are actually solving this. So how do they do it? Well, they step through a few key mechanisms. First, efficiency efforts, like building internal closed-loop water recycling systems so they aren't constantly draining outside fresh water. Second, process innovations, such as upgrading equipment to reduce aquatic impingements, which basically means making sure they aren't trapping marine life in their machinery intakes. And finally, using advanced global analysis tools, like the WWF Water Risk Filter or the Global Water Tool, to proactively navigate risks before they become a problem. Ultimately, this proves that proactive resource stewardship and careful waste management aren't just some annoying regulatory burden. They are powerful drivers of long-term profitability. Implementing these strategies directly lowers operating costs over time and shields the company from the financial shocks of supply shortages or fines. It's a perfect example of how environmental conservation equals a real competitive advantage. I want to leave you with this final thought to consider the next time you hold a packaged product in your hands. As climate change accelerates and resources shrink, is your packaging provider a steward of the future or a liability waiting to happen? By measuring water consumption in stressed regions and tracking the true life cycle of toxic waste, we finally have the tools to tell the difference. Thanks for joining me for this explainer, and I hope this gives you a whole new perspective on the true cost of packaging.